Hello everybody, welcome to my course, that is reactive intermediates, carbenes and nitrines. We were discussing in my previous class that the importance of nitrines and their structures and hybridizations, how they will behave in different type of reactions, what are their characteristics and their application part. We have discussed those things. So, today we will discuss this nitrogen analog of carbene, that is the nitrines generation. Okay. So, what we will discuss? Generation of nitrines. Okay. We have already mentioned that nitrines are actually the nitrogen analog of carbenes and they possess almost similar type of structural features, characteristics, as for example, like they also having 6 electrons and they are also solid species, transient species. Okay. So, they also behave in a similar manner like carbenes, but due to having some different structural features, they are giving different reactivity in certain cases. Okay. So, in similar like carbenes, now nitrines also can be generated through various ways. If we see in case of carbenes, one of the most used method was to thermal or photochemical decomposition of diazo compounds. Okay. So, in this case, if we wanted to generate now the nitrines, what could be the most used or what could be the first choice? That is obviously in that case, like carbenes case, we have decomposed the diazo compounds. So, nitrogen is eliminated and the carbene, that electron deficient carbene species generated. In this case also similar way, as it is the nitrogen analog of the carbene. So, we can actually go for this thermal or photochemical decompositions of what? Of azides. Okay. So, first method that could be the thermolysis, or we can call or photolysis. Okay. Okay. So, in this case we have to irradiate azides, okay, either heat or H nu depending upon the requirement or reactivity, we can actually generate the corresponding nitrine and what it will liberate? This will liberate the nitrogen. Now, what is this azides? Azides are nothing but this species. How we can synthesize this azide? Any idea? Okay. So, azides can be nicely synthesized starting from alkyl halides, mostly halides could be bromide chlorides or iodides, with this sodium azide as a azide source. If we simply use it, this will give directly the corresponding alkyl or aryl azides. That could be the nice precursor for the generation of nitrine. Okay. So, in this case, and how we can detect that azide has formed in the reactions as a starting material? Because again this could be also nicely detect through IR spectroscopy, okay, infrared spectroscopy, and in this through this spectroscopy actually some stretching particular stretching frequency is there around 2100 centimeter inverse. There if we see that nice peak will come, then we can confirm that azide has formed from the corresponding alkyl halide where that band is absent. Okay. So, in this case if we use thermal or photochemical irradiation, then what it will form? This will form the nitrene, okay. Or this R here could be alkyl or aryl. You can take sulfonyl azide, okay. Under similar condition, this will also give the corresponding nitrene with the nitrogen elimination. Okay. Similarly, if you take alkyl azidoformate as starting material, so this will also give this carboalkoxynitrene, this will generate this carboalkoxynitrene with nitrogen elimination. So, in all these cases we can generate through thermal or photochemical irradiation the required nitrene as a reactive intermediate, okay. And these are all very short light species which are very much reactive, okay. And this particular nitrene, there it has been found that these are more selective, okay, more selective in nature than corresponding carbenes. Carbenes are very reactive, most of the cases they are inserting in non-selective manner, okay. But this particular nitrene, it has been found that is pretty nicely, it can give lot of selective reactions. However, apart from these thermal or photochemical decompositions, the azides can be converted into its nitrene through the nitrogen liberation in presence of transition metal salts, okay. So, that also possible apart from these cases, okay. So, these decompositions of this azide, that in presence of transition metal salts also give nitrines, and actually it has been explored in various ways in recent days that these nitrines can be actually inserted into lot of bioactive molecules in their latter stage. I mean, that is having various type of functional groups. Among that also it can be selectively inserted into certain position of these complex molecules, and that way these transition metal salts are nowadays very important to generate this type of nitrines, okay. Another way that nitrines can be generated from, that is called ylides, okay. So, first we have seen that from the azides, next it will be from ylides. You can give this is B, that is A, okay, from ylides. So, from ylides. So, if you take, these are not that common like a carbon, its carbon counterpart, but there are possibility that, okay, and here X could be SME2 or NMe3. So, they are actually giving this type of ylides, and these are called iminophosphorane or iminosulfuran, and these iminophosphorane or iminosulfuran in presence of H nu actually gives that corresponding nitrene, okay. We will see later many examples with those things. Another precursor for the synthesis of these nitrene species could be the small rings. So, from small rings, okay. In case of carbenes, we have seen that if there is small rings like epoxides kinds of things, that can be actually converted into the carbenes under thermal or photochemical irradiations. Similarly, here if we have this type of ring, as per example here X, Y, we can write like this, okay, under thermal or photochemical conditions, that gives the nitrene plus some small molecule will be eliminated. Okay. If we take oxygeridine as per example, as a precursor for generation of nitrene through this way, under photochemical irradiations, this oxygeridine ring will generate one small keto compound plus the corresponding nitrene. Okay. So, there are three ways that we have so far discussed. One is from the azides, that is very common or very famous. Then the nitrenes can be generated through ylides, or they can be generated from various small rings through the decomposition of that small rings leads to the corresponding nitrene and the elimination of some small molecules. In this case, this oxygeridine ring gives the corresponding keto compounds as a small molecules, these benzophenone type of molecules, and here this nitrene that has been generated as the reactive intermediate. Okay. Next, these nitrenes, another method, this can be generated from isocyanates. We have seen in case of carbenes, when we have generated the carbenes from wanted to generated carbenes from similar cases, what we have taken as a precursor? Yes, we have taken that precursor as the ketenes. Okay. As per example, what we have taken there, that okay. So, from there we got this okay, for the carbene. So, in case of nitrenes, what will be that? In that case, yes, yes, you are correct, that is from the isocyanates. Sorry. From isocyanates. Okay. So, isocyanates means the structure, if you can think about the ketenes, then isocyanate is this. Under now photochemical irradiation, so this will give the corresponding nitrene plus carbon monoxide elimination. Okay. And this will be generated here nitrene in a similar or analogous way of generating carbene from the ketene. Here also in similar conditions, this will be giving the required nitrene species. Okay. As per example, take this particular isocyanate under photochemical irradiation, what has formed? So, this has formed the corresponding carbazole moiety through the generation of this nitrene species. Okay. So, what it has generated? So, this has generated one very important nitrogen containing heterocycle, that is called carbazole. So, this is the carbazole moiety that can be generated from these isocyanate precursors under the photochemical irradiation. Okay. Similarly, another method is there through that we can generate the nitrene precursor, and nowadays it becomes very popular due to its easy handling, as the azides are what we said, that azides are most common and useful, but lot of cases azides are very hazardous and they are explosives also. Okay. After certain temperature, most of these azides they are decomposing and they can explode. So, there are some potential potential limitations are there for these azides. So, in that case these various techniques to generate nitrenes has evolved because of the these various problems with the azide compounds, and their fast decompositions actually leads to develop various other sources of for generation of the nitrines. As for example, if we take these heterocycles, so from heterocycles, okay. So, take this heterocycle, okay, under thermal or photochemical irradiations. This can again eliminate a small molecule and give the required nitrine species. Okay. So, these are the way that from heterocycles also we can generate the required nitrine species. Okay. As per example, if you take some oxazolone moiety, that is 1,4,2 dioxazole 5-one, this is okay. This is the 1,4,2 dioxazole 5-one moiety, and if we under thermal or photochemical conditions, actually this will liberate the carbon dioxide, okay. Sorry, this will liberate this carbon dioxide moiety to give the corresponding nitrine. Okay. So, this particular way we can liberate the carbon dioxide and then generate this acyl nitrine moiety. Okay. Another similar heterocycle, that is this anthranil type of moiety, under high temperature or under transition metal salts, it can give the corresponding nitrine moiety, and this could be used for array lamination of various substrates. Okay. So, nitrine is generated. Now, this nitrine can be used for various type of reactions. Importantly, here it is the phenyl nitrine or aryl nitrine that has been generated. Okay. We have discussed previously also that not only the through this thermolysis or photolysis, there are other method that can also leads to the carbene. We have discussed in case of carbenes, as for example, alpha eliminations. In this case also we can think that alpha elimination can provide the required nitrine. Okay. So, if we take this particular substrate and treat it with base, we have seen in case of carbene also, if we use base depending upon the basic strength. So, that could be used to deprotonate, and then the elimination of that leaving group. Here it could be halides, it could be other leaving group also. So, in presence of base, if that will pick up this, then obviously okay. Now, the alpha elimination that will lead to the corresponding nitrine. Okay. So, this is another technique apart from the thermal or thermolysis or photolysis of the azides. This is another way that alpha elimination can be done to get the required nitrine moiety. Okay. Not only that, another method is also there, this is called the reduction of nitro or nitroso compound, that can also lead to generate the required nitrine moiety. So, reduction of nitro or nitroso compounds. As per example, if we take this or nitroso compound in presence of some phosphines, this will give the corresponding nitrine. Okay. So, what will happen if you see the mechanism, how does it work? So, we have this is our nitro compound. Okay. So, now we have this phosphine. Okay. This can attack. Okay. So, what we will get? Okay. So, now this can go back, and as phosphorus and oxygen having very affinity towards to each other. So, this bond will cleave and we will get this phosphine oxide. Okay. So, once it will be eliminated, then what it will form? It will form the corresponding nitroso, and once you have this nitroso, then again in presence of phosphine. Okay. So, okay. And now the alpha elimination, again due to the affinity towards this phosphorus oxygen bonds, okay. So, now what it will form? This will generate the corresponding nitrine moiety, okay, through the okay. So, what we have seen, that we have seen not only the thermolysis or photolysis of azides, which is very common method, not only that, other methods also similarly important, either it is by the different type of formation of nitrines from different type of heterolysis of from different type of heterocycle through the thermolysis or photolysis, or it could be the alpha elimination, or it could be the reduction of nitro or nitroso compounds. Similarly, another method also there, that is the, I have already shown once that when we have discussed the stable nitrine compound which is possible to detect, that there we have mentioned that hydrogen type of moieties also can be oxidized to get the nitrines. Okay. So, that way we will also discuss that there is another method, that is called oxidation of amines or hydrogens. Okay. So, if we take amines and in presence of some oxidant, okay, this will give the nitrine, or hydrogen moiety, that is also in presence of oxidant, will give certain nitrines. Okay. So far what we have discussed? We have discussed the various technique of generating the nitrine moiety. It is not only the photolysis or thermolysis of azides, but also we can generate those nitrines from various small molecules, heterocycles, or from the alpha eliminations, or from reduction of nitro or nitroso compounds, and could be oxidations of amines or hydrogens. So, these processes has been evolved due to the certain certain problems with various azides, due to their stability problem, as it can explode very fast or as it can explode after certain temperatures, and most of these azides are also not very stable moiety. So, handling of those azides also pretty difficult. So, with that aspect, actually these different type of techniques has been evolved due to various applications. Next class we will discuss the different reactions of nitrines. Okay. Thank you.